Yes, ma'am.
Yes, ma'am.
Yeah. So in yesterday's lecture, we started with the discussion on how we actually write a C program and what are the stages which go behind the compilation and finally the execution of it. And then we saw the basic elements of the C language, right? Do you recollect? This particular snapshot gives you the different language elements, C language elements in a nutshell. So um, again, to just recollect, the language elements are preprocessor directives like hash include, hash define. Then you have um, variables. You have constants which can be defined using hash define. You have variables. You have standard identifiers, identifiers which are present in the C header files, in the C standard libraries. Then you have the concept of reserved words. Okay. Then we also saw comments. Okay. So all these actually form the C language elements. Moving on, uh, we talked about the rules for defining identifiers. Do you recollect the rules for defining identifiers?
No use of reserved words.
No use of reserved words. Okay, very good.
And start with a
Go ahead.
digit.
Cannot start with a digit. Very good.
It cannot
There
have
should be
special
no space.
characters.
No space, only
Don't use
underscore.
special characters.
No space or special characters. Good, good. Yeah. So it can contain combination of letters and digits. It should not start with a digit, and special characters are absolutely not allowed. Okay. So these are the rules, and of course you cannot use keywords or reserved words. Now, when C, the language C is what is known as a case sensitive language. Okay. That means the example given on this slide says rate, rate, and rate, although the case of all these three words is different, right? The word is the same,
Ma'am, I
but
think we
what
can't see the slide.
you cannot see it again. Okay,
Yes, ma'am, it's still stuck on 23.
okay, okay. I'll share again. Now, if I change, can you see it? Just tell me. Are you able to see?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
yes,
Yes,
ma'am.
ma'am.
Yes.
Yes,
Yes,
ma'am.
ma'am.
Okay. So rate, rate, and rate, these are viewed by the compiler as different identifiers because of the fact that C is case sensitive, right? Um, so this is the convention, as I told you. The naming convention is whenever you are having constant macros, whenever you're defining constants in your program, you use the uppercase letters to define them. Okay. And if you're going for variables, then use the lowercase. That is the convention which is adopted by the industry. That's the standard naming convention. Okay. So this is about examples for the macros, the constant macros. Then for the variables. So a variable is like we discussed yesterday. It is a name which is associated with a memory cell whose value can change. So you can keep on changing. On the other hand, that constant is a fixed value. You cannot change it throughout your program. It is fixed. Once you say it's hash defined pi some 3.1416, you cannot make it 1417. You cannot change it in your program. Okay, so the first thing that you have before you use a variable is known as a variable declaration. You need to declare beforehand, before you actually use it in your formulae, in your program somewhere. You need to declare that variable. So variable declarations are statements that communicate to the compiler two things. First is the name of the variable. Of course, you need to give it a proper name. And second is the kind of information which is stored in each variable. So the syntax for this variable declaration is this. So you have integer followed by the type, basically followed by the type, which is followed by the variable list. Okay, so if you have multiple variables of the same type, you need to specify the kind or the type of the variable. Okay, and C has this division or categorization of different data types. So integer, which is a whole number, negative or positive included, and positive included, that is represented by this keyword int. Okay, when I talk about floating point numbers, decimal numbers with a floating point, they are represented by two types. There are two types which are available. One is a float and second is a double. Okay, so again you will see all this in red. These are keywords. Okay, and one more type is for representing characters. So character is something which is not a number. Okay, so and it is included in single quotes. So if I want to say something like, if I have a character in my program, that is char C, yeah, it's given here. So if I have this char first initial in my program, then if I want to initialize it, I can use the assignment operator and I can say first initial is equal to, okay, it is included in a single quote. A char type, char, is a character, it is included in a single quote. A char type is very useful when we are dealing with what is known as a string. Okay, and string is nothing but a sequence of characters. A string is nothing but a sequence of characters. So when we deal with strings, because many times what we need to do is we need to deal with data where we're dealing with names. So for example, if I'm considering FEIT class, okay, so I have all student names, right? And I want to sort these names in, say, the order of the surname. So I'm dealing with scenarios where I have to deal with data which involves strings, right? So string handling is an inherent part of every programming language. So C also supports that. And for creating a string, we use an array of characters, a sequence of characters. So the type used is char, basically, inside it. Okay, so we'll come to it when when we talk about arrays. Okay, so char is one more type. And just a minute. And whenever you have these variable declarations, all of these variable declarations end with a semicolon, if you notice. So if you forget the semicolon, there's a problem. Okay, yes, what is your question?
Ma'am, what is syntax?
Syntax is basically the rules of the language. Okay, so you can say, like, you can correlate this with grammar in a natural language. Okay, so I cannot make a sentence like, um, he is a student. Instead of that, I cannot say is he I cannot swap the words. Okay, it will mean something else, or it might be nonsense, it might not make sense, right? So similarly, syntax in a programming language is the way in which I write my statements. So I cannot write something like, instead of int count here, which I have in this example, I cannot write something as count int. Okay, because that is a rule which governs the language. I have to follow that rule. So it always has to be, for variable declaration, it always has to be data type followed by the variable name. Does that answer your question?
Ma'am,
Yes.
can integer come in the quotes for char?
I didn't get your question.
Can we put digits or integers in quotes for char?
Good question. Yes. So the answer is yes. A char is a single character. Okay. So if I have something like 5, single character, it has to be single. I cannot have 50. If I put 5, if I have 5, fine, I can put that in single quotes. Okay. I can say that first initial is equal to 5 or answer is equal to 5. Okay. I can do that. But I cannot perform any mathematical operation on it, because now it is in quotes, right? So it is isolated. You cannot perform a mathematical operation on it. You can perform some specific operations like comparison on it. Okay. So I can compare this. I can check whether, suppose you are asking the user to enter some value and you have some value stored with you. For example, I have this answer with me and I have you answer as another char variable. So okay, I have char you answer, right? And I have read this from the user. So I can make a comparison like, is answer equal to you answer? I can you answer. And to make a comparison, I need to use a double equal to operator, which we'll see when how do we what are the kind of comparison operators in C. Okay, this is allowed, but mathematical operation is not allowed directly on it. Okay.
Thank you.
Yeah.
Ma'am,
Yes.
we cannot put double digit. Only a single digit is allowed in char.
In
Hello?
code. Yeah. Now see, this char is a very it's a tricky data type, I can say, for now, because when I have a single quote, so when I'm putting it like that, it has to be a single digit only. But in C, what happens is every character is represented with what is known as an ASCII value internally, because ultimately it is represented by a number inside memory. Okay, it is translated to some number. Okay.
Okay,
See,
ma'am.
because what happens is internally when you represent, everything is in zeros and ones. Even your names is converted into some number and then it is saved as zeros and ones, right? So it cannot be like I'm saving S there or N there or K there. No, I cannot do that, right? I need to ultimately convert it into numbers, because everything is zeros and ones. So there has to be some representation for each of these characters that I have. Every letter will have a representation, every digit will have a representation, every key on the keyboard that I have will have a representation. Okay, and that is known as an ASCII representation. I will come to this when I discuss about characters and strings. Okay, I'll revisit this because right now it is not important.
Okay, sure, ma'am.
Yeah. Can I proceed?
Yes, ma'am.
Okay. So the data type that I told you earlier in the earlier example, int, double, these are data types. So what is a data type? How do you define a data type? It is a set of values and operations that can be performed on those values. So depending on whatever is a data type of a variable, you can say that, okay, since it is an integer, I can perform arithmetic operations on it. Okay. So not only the range of values, so there's a range, you will see. So for example, on this slide, you can see a range, right? Integer is having this range of -32768 to 32767. So it is 16-bit. Now what is this? Okay. This is nothing but how it is represented in memory. How much space it is taking inside computer's memory. So integer here is 16-bit in this example, but again this 16-bit varies. Okay, some machines, okay, where the 16-bit is now become old actually. Most of the compilers which are there, they are 32-bit compilers or 64-bit compilers. So the integer actually is a 32-bit number that you see. In some compilers you will still find, some old compilers you will find the range to be 16-bit. Okay, now what is a bit? It's a binary digit, 0 or 1, right? And 16-bit means how many bytes? Do you know what is bit byte?
Yeah, ma'am, 2 bytes.
2 bytes.
Correct. So 1 byte is actually 8 bits, right? That is a
Yes, ma'am.
conversion. Yeah. So when I say 16-bit, what becomes the range? What should be, how many numbers
2
can be
raised to
accommodated?
16.
2 raised to 16. Very good. 2 raised to 16. And what is that value?
32768.
No. It's a double of this. Right? Just can someone just quickly find out 2 raised to 16 on some tab there right next to you?
65536.
65, 536.
6, 5,
536.
5, 3, 6, right? These many numbers can be accommodated in 16 bits. Integers can be accommodated in 16 bits. Okay. But an integer should support negative as well as positive value, right? Integers are negative as well as positive, as well as it has that 0. So what will happen logically? The range will be divided by 2. Yes or no? Because half of the numbers will be on the
Yes.
positive side, half of the numbers will be on the negative side, right? So the numbers, the range is divided by 2. So it comes out to be, what is this 32768? Just find out.
Ma'am, can you explain how 2 raised to 16 came?
It's 16-bit in binary, so I think digital, it's a little to do with the digital math. Okay, anyways.
For each
So
bit,
when I have
0 and 1, 2
yeah,
numbers.
I'll just tell you. 16-bit means it's in binary, right? So suppose I'm talking about a 4-bit number. Okay, what are the numbers possible? You know binary number system, all of you, or some of you do not know what is binary number system?
No, ma'am, I don't think.
No, ma'am.
No, ma'am.
No, ma'am.
Okay, yeah. So what human beings use as usually, or we use in math, that is a decimal number system. Everyone knows, right? Why is that the decimal number system? Because there are 10 digits, 0 to 9. Okay, once, so I have, if I want to represent the numbers, I say 0, 1, 2, 3. Once I'm done with 9, I start with the combinations. I start forming 2-digit numbers, right? So the next set of numbers will be 1 with all the combinations with 1, right? 1, 0, 1, 1, 1, 2, right? Then you're exhausted with this, then you start from 2, 2, 0, 2, 2, 1, 2, 3. Okay, this is the decimal number system. Then once you're done with all the 2-digit numbers till 99, you start with the 3-digit numbers, again with the combinations, right? So this is one number system. This is one of the very popular number systems which we are accustomed to. We have been doing all our computations in math. We've been using it daily on a day-to-day basis. This is our decimal number system. Okay. Now there are so many other representations or number systems to represent numbers. Okay. And computers, when we talk about digital, when we say it's digital, so everything is in zeros and ones. So the computers use what is known as the binary number system. Fine. So binary number system has only 2 symbols, 0 and 1. Decimal has 10. Binary means 2 by 2, right? So binary has two symbols or 2 numbers. Now, once I'm done with this, what is the next combination that I have? I have 1 0 and 1 1, right? Then I'm done with the 2-digit binary numbers. Then 1 0 0, 1 0 1, okay, 1 1 0, like that you will form the combinations. You're exhausted with 2, then you're exhausted with 3, then you're exhausted with 4. This is binary. Are you getting the idea of binary? Somewhat. What is binary?
Yes, ma'am.
Yes, ma'am.
Yeah. Now the thing is, every number that I'm considering in the decimal number can be represented in the binary number system as well. Okay. So if I'm considering a number like, okay, the first number that I have, this is my 0 of decimal. The second number that I have is 1. The third number that I have written here is 2 of the decimal. This is 2. Fourth number is 3. Fifth number is 4, and so on. All these are actually the decimal equivalents. Okay. Now, given a decimal number, how do I convert into binary? Okay, how do I convert it into binary? The way to convert it into binary is to divide, keep on dividing it by 2. Have you heard of this? Those who know. So if
Yes.
my number is 11,
Yes,
if the decimal, yeah, if the decimal number is 11, I keep on dividing it by 2. So 2 5s are 10. What is the remainder I write here? Again, 2 2s are 4. What is the remainder I write here? 2 1s are 2. Whatever is the remainder I write here. And finally, whatever is remaining at the end, it's not divisible by 2. I take it out. That is 1. And I read this. And I read this upwards, right? So the binary equivalent of 11. So I say 11 base 10. That is decimal number. The binary equivalent of this is 1011. Okay. Now, whatever integer I have, are you getting it? Whatever integer I have will have a equivalent binary representation. Okay, and there are this is only about positive representation that I've shown right now. There is a representation for representing negative numbers as well. I think you will be studying that in digital, that subject where you're going to study about digital electronics. You have it right in the first time, microprocessors, something. So
Yes,
there,
sir.
I think you'll be introduced.
Electronics have it in second sem.
Okay, wherever it is, but just this is just an idea. You don't need to go much into detail as far as C is concerned. I'm just talking about how the representation is. Okay, detail, all that negative, positive, everything will be discussed. That you will learn eventually. Only thing is, when I talk about 16-bit numbers, so how it comes out to be 2 raised to 16 is because
Each bit has two possibilities. So
yes, exactly. So each bit has two possibilities. So for 5 bits, it will be 2 raised to 5. For n bits, in general, n bits will have 2 raised to n number of.
Ma'am, but integer occupies 4 bytes, so it means that it is occupying 32 bits. Any integer.
No. See, in this example, that is what I'm saying. This is compiler dependent. So if I'm talking about a 16-bit compiler, the older compilers, nowadays we don't find them. But when C started, the integer was 16-bit. A few years back, we still had 16-bit compilers, but nowadays I do not see 16-bit compilers. 16-bit machines are not there nowadays. We have only 32, 64-bit machines. Okay, so this has something to do about the compiler architecture, memory architecture, which we are not going into right now. Okay, so the older versions were 16-bit, but nowadays most compilers will give you int as 32-bit. Okay, so this has become a little obsolete, I can say, but this is a beginning. 16-bit hai to 16-bit, but how do you understand then what is the size? So 32-bit it is, as you have rightly said, whoever you are. I cannot see the name right now, that is why I'm saying that way. Anyways, so this is 32-bit. Okay, int is 32-bit, so it becomes 2 raised to 32. The number of numbers that it can accommodate is 2 raised to 32. And if you're considering positive as well as negative, it becomes half. So what is that? half the numbers will be on one side, half the on the other. Okay, there's a 0 in between. That is why on one side there's a 7 and one side there's an 8. Are you getting it?
Yes, ma'am.
Yes, ma'am.
Yeah. Next is a double. Double is a real number. It is a floating point number. So it has an integer part and it has a fractional part, which is separated by a decimal point. Okay. This is the double type. So this gives you a gist of the integer type. So now in integer also there are different types where you can actually make specialized kind of integers. So if you are talking about an integer, and if you want to go for, now since integers are signed, they are signed because they're having negative as well as positive numbers, you can have an unsigned int. Okay, that unsigned int will give you all the numbers from 0 to 65535. So all 65536 numbers will be there in unsigned int, or only unsigned. If I only say unsigned also, it will still be the same. Then you have something like short. Short will reduce it to half. Okay, so short, if you want to find this range for your particular compiler, then you can do this using the size of operator. So I will just show that to you. Have you used the size of operator?
No, ma'am.
Okay. So can you see this code, my screen?
Yes, ma'am.
Yeah. So what we are doing here is we are trying to find out the size of the types which are there on this particular compiler which I have installed on my machine. Okay, you can find it on your machine as well. You can check the online compiler as well. You can do this anywhere on any compiler. Okay, so for checking the size of a type, you use the size of operator. You say size of, and into parenthesis, you specify the type. Okay, and since it's returning a value, I hope you have used printf with the format specifiers, all batches.
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
So there are many format specifiers. You must have used %d, you must have used %f, right?
Yes,
So
ma'am.
Yes,
which
ma'am.
ones you have used? So depending on the type, that is the type. So this size of returns a long unsigned int. Okay, so right now don't worry about what it is. So the format specifier for that is %lu. Okay, that is why you will see this as %lu. Now when I run this program, you will see char I have printed, int I have printed, float, double, short, unsigned, long, some of these. You can try with others also. I'll give this program to you. You can try it. Okay, if I run it, okay, so it has printed. Of course I have not printed. So first is the char. So what it is giving you 1, the output is 1. That means it is 1 byte. So the size of operator returns the size of the type that is passed to it in bytes, in terms of bytes. So size of a character is 1 byte or 8 bits. Okay, size of integer is 4 bytes on my compiler. Okay, that is 32 bits. So in most of the compilers that you have right now, you will have they are 32-bit compilers. So you will find that means the memory that is there. What is the meaning of 32-bit compiler? That means the kind of memory representation that is there, that is 32-bit. Okay. So 4 bit, so 4 byte. Size of float is also 4 byte. Okay. Although float and integer is different, they will have a different range because float is a number with a decimal point, right? Float is a number with a decimal point. Then you have double. So size of double is double that of float. So 4 2s are 8, right? So 8 bytes. Then of short, it is 2 bytes. So it has reduced integers to 2. Okay. So if it is a 16-bit compiler, then size of int and size of short is the same. But if it is a 32-bit compiler, then in that case, size of int short is half the size of int. Okay. Then you have size of unsigned long. So long is the same as int here on a 32-bit compiler. But if it is a 16-bit compiler, you will see the difference. Okay.
Ma'am, why did you write that percentage LU? Is it necessary to write, or can we write anything else?
You can write something like %d, but it throws a warning on some compilers because the return type which is specified, this is an operator and it is defined, predefined. Okay, this size of operator. So it is expected that this operator returns whatever that 4 bytes it is returning. The way it is defined in the C language, that is an unsigned long int. It is an unsigned long int. That's why you need to write it %lu. But C will still ignore it and it will throw you a warning rather than an error. Have you seen a warning somewhere when you ran the first in the first experiment? Did you get a warning sometime?
No,
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 ma'am.
One ma'am, too many arguments आया था एक बार, but then I had to stop the program. मतलब I couldn't make any corrections.
So
मैम एक बार
warning
सेमीकोलन भूल गया था तो
that is an error. That is an error. Warnings and errors are different. There are two different concepts. One is the concept of a warning, one is the concept of an error. Warning is something that you are making some mistake, but it is okay, chalta hai, theek hai. Mistake is okay, but that might be costly later on. So don't go for, some of the people, they ignore warnings. It will run your that means your object file will be created. If a warning is thrown, your object file is still created, but that warning is like it is giving you beforehand that it might run into trouble. Your program might run into trouble during runtime. Okay, that is a warning. Okay, due to some circumstances, not in every case. And error is something that your object file will not be created at all in case of C. Why? Because it is a syntax error. Your program is syntactically wrong. You have forgotten a semicolon, for example. That's a syntax error because you're not following the rule only, and your program will not run. Your object file will not be created. That is an error. Okay. I will definitely give you some links to read about warnings and errors. Okay, by this weekend, just go through those links and try to understand the difference. Anyways, so this is about the size of operator, and if you want to see the size of any data types that you have, okay, again, we do not use most of these. We just go for char, int, float, double when we are going about the experiments and stuff. We are not bothered about unsigned long and stuff a lot because we are more bothered about problem solving rather than looking at the data right now. Okay, of course, you cannot use, instead of a string, you cannot use integer there. Of course, that relevance has to be there, but we are not going much into detail like short or unsigned int. So again, there's a lot. You can read through it, go through it, and you can just navigate through. Okay, these are the types which are available. Later on, if I have to build some application which involves C, then I can go for this. You should be aware, that is the idea. Don't go much into detail about this. Okay. Then you have these floating point types which are there. You have float, double, you have long double also, which is available, which is 80-bit. Okay, it is not exactly the double of double, but it is 80 bits. Again, these are the approximate ranges which are there. So actually what is the difference between float and double is, double increases the range. So the number of numbers that can be accommodated inside double is high, and the number of significant digits is also high. Okay, so for example, float has 6 significant digits and double has 15. So you can see as the size increases, the precision and the range increases. Okay, that is the only difference. Next, the data type char, which was not discussed in the earlier slides. So everything in a single quote. It's a single character. It could be a letter, it could be a digit, it could be a symbol, it could be any key on the keyboard. Okay. Then these are some examples. You can go through this. I'm skipping this. Just go through this slide. Okay. Next is executable statements. Executable statements are basically whatever you're writing in your algorithm. Did you start with the algorithm steps? Did you start writing algorithms yet or no?
There was just one lecture, but we didn't start writing.
Okay, not start any so far, no? Okay, fine. So basically, whatever you're writing, whatever steps that you write in your algorithm, that has to be translated into executable statement. That gets translated to an executable statement. So basically, the formulae that you have, if you have some kind of formulae, that is an executable statement. So if you're calling a printf function or a scanf function, that is an executable statement. And all these executable statements, they end with the semicolon. So all the statements, in fact, are executable only. The first part of the C program, it starts with, inside main, the first statement that you write is a variable declaration, other variable declarations, and followed by that you have a list of executable statements. That is a flow. Okay, so this screenshot actually shows the memory which is before and after the execution of a program. So in these are the variables. If you remember, the program which I had shown last time was this only, that is miles to kilometers. Do you remember?
Yes, ma'am.
Kilometers. Yeah. So there were two variables in that. One is the miles and one is the kilometers. You have to convert the miles into kilometers using the conversion factor. You remember miles per kilometers was one hash defined macro constant.
Yes, ma'am.
Yeah. So sorry, kilometers per mile. Yeah, kilometers per mile. Yeah. So what you do is you are taking that number from the user miles and you are displaying that converted result into kilometers again. Okay. So what happens in memory in the background is given in this diagram. So miles and kilometers, of course, are variables which you will declare. Okay. So the moment you declare those variables, what happens in the background? The variables are allocated memory depending on the type. So miles and kilometers, they are float. They were float or double, I don't remember. Float, okay, whatever it is, those many bytes are allocated to it. Okay, that free memory is allocated to it. And what is there, what is stored inside that memory, that is garbage. Okay, that is garbage in C. I do not know, it is known as garbage. The question mark is nothing but a garbage, because I do not know what it is and I don't care what it is. Okay, but once I run it, I am taking miles from the user, right? I am doing a scanf. If I go back to the, let me see if I can go back to the program. Yeah. There, that was double. Yeah. So I am doing a scanf here, right? I am reading the distance in miles, okay, from the user. The moment I read this distance in miles using scanf, I will come to scanf after this, shortly after this. What happens is that memory which was reserved, when was the memory reserved? As a result of this statement. Whenever I do a variable declaration, the memory is reserved. Okay. Now, when that memory is reserved, once I use the scanf will initialize that memory to whatever the user is entering via the keyboard. Okay, so you have entered something, miles is 10, so that whatever garbage is replaced by 10. That is what happens. And then you're computing this using this formula. Okay, you're computing kilometers. And as a result of this assignment that you see here, you're saying kilometers is equal to this formula, and this formula will be some value. That value will be actually saved inside kilometers. So the converted value that we have is 16.09. Okay. So that is what happens after the execution of the program. Okay. So assignment statements, you have used assignment statement. Assignment operator, there's an operator which is the equal to operator, which is known as the assignment operator. The equal to is known as the assignment operator. It is going to store some value into a variable. It is used to store a value to a variable. That value is on the right hand side of it. Okay, so left hand side will be the variable and right hand side will be the value, or it will be an expression. Okay, it will be an expression, it will be a formula. This expression, in fact, I can say this expression could be a value or it could be a math formula. Fine. So both are allowed. This is an assignment statement. Example is given. You have used this. You have already used this, right? In the calculator program, you have used this. So again, everyone has understood now what is happening, what was there, what was the picture before assignment, before the program was running. It was containing garbage. And then after assignment, what is happening is, okay, this is before assignment. This is before assignment. Kilometers per mile is my constant, which is there, which I have defined already. Then miles is 10, which I have taken from user. Kilometers is not computed yet, right? So what is happening is you apply the formula, you are getting the result here. Okay, the result is saved into kilometers as a result of the assignment operator. How is this save being done? Using the assignment operator, because there's that value is computed, but where's the value saved? It is there in temporary buffer. But unless and until you make that assignment to kilometers, that will not be saved, right? See, what I'm doing is I'm making this kind of an expression. This I'm saying this is my expression, right? This is my kilometers per miles into miles is my expression, right? Now this value, whatever is computing, it is there. 16.09 is there, but I have not saved it into my variable so far. The moment I say kilometers is equal to this, then that assignment happens. Then that value is saved in the memory of kilometers. That is how it works. So this is nothing, but this is very simple. This looks very simple, but this is what is happening in the background. And you should know this, how it is getting saved, right? So that is about the statement memory allocation, how the variable memory allocation, how the variable is assigned memory, and then it is containing garbage initially, and after you write all the valid formulae and you do some kind of an assignment, or if you're reading from scanf, then that memory is changed with the value. Okay, again, this is one more example for the second example. Are you getting the idea of assignment? What is happening? Or any doubt?
Yes, ma'am.
Simple, right? Yeah. Then you have input, output, operations, and functions. So input, output, you already know. Input is scanf, output is printf. Input, output function. So they are actually functions only, which are available in the standard library. Okay, and what we do inside it when we write that statement, scanf something something %d or something, or printf with hello world, whatever, then that statement that we are writing is nothing but a function call, right? You're calling a function which is already defined in the library. You're calling or activating a function which is already there. It is defined. You just have to use it by providing the actual real-time values. You're providing some values for it to work. Okay. So let us see printf. Printf is, everyone has done printf. So everyone is aware of printf. So it is having the function, it is enclosed in parentheses. All functions have parentheses where you're passing the data, the parameters, or the function arguments. Okay, they're also known as function arguments. Whatever you're passing inside that parenthesis, whatever data you're writing inside that parenthesis is known as an argument, or it is known as a parameter for that function. Okay, format string you're aware of. It is using double quotes. Okay, it is a string of characters and enclosed in double quotes. Okay, so they specify, it is used to specify the form of the output line, how your output is going to look. So when I'm talking about the printf function, how will your output look on the screen? So that exact sentence you have to write it there. Okay, inside those double quotes. And print list is the list of variables which you are going to use along with the printf statement. So inside the printf statement, if you want to print some values, variables values, then you pass those variables by writing commas after the format string. Okay, so this is the general example. Everyone is clear about how to write printf? Everyone in the class is clear about how to write printf?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay,
मैम
so
एक बार
percent-
वेरिएबल लिस्ट डाला, उसके बाद we cannot use format strings again, right? Comma
no,
डाल
this
के.
is the syntax. That is what I am saying. The syntax says first you write the function name. Okay, then you have the function arguments inside parentheses. Now the arguments have to follow the order in which the function was defined. Remember this, whenever you define a function in C, you have to follow the order in which they were defined originally. So what is the order which is there? The order is first is the format string and then is the argument list. So you cannot have the format string afterwards because that's a rule, na? That's a syntax. Are you getting it?
Okay, ma'am. Yes, ma'am.
Yeah. So this kilometers is corresponding to %f. This is clear, right? This diagram is clear.
What percentage F means?
%f is called a format specifier. This format specifier actually tells you, it allows you to distinguish what data type your variable is. So if it is a %d, it's a default data type, and default data type is an integer. Okay, you can also write a %i instead of %d, it will still work. By default, it is.
And so for double, what do we use? Like %d we are using for integer.
Yeah, %lf.
LF.
Long float is double.
Okay.
Okay, so there are different format specifiers depending on the type. Does that answer your question?
Yes, ma'am.
Yeah. So again, it's given here. So symbol beginning with %, it indicates where to display the output value. Where means here inside it's going to display, na? Okay. And what is the type of the value? Yeah. And this is new line. You see one new character here. This one, na? This is a \n. Now this \n is a special character. It's called as an escape sequence. There are different escape sequences which are available in C. Suppose you want to create a new line after a statement, then you put a \n. It's a backward slash, \n. Okay, it will leave a new line after your statement. So whatever next you write in your program, that will come on the new line. Okay. There is also one more, that is \t. That stands for a tab. So it will leave a tab space in your output when you're printing. Okay. So the placeholders are, or the format specifier is also known as a placeholder. They are given here some for the basic types. Anyways, next is, there are some more examples. That's fine. Now this is just something extra, is when you want to actually make your program more user friendly, you will not directly write a scanf, right? If you want to read data, you will put a prompt. Okay, So prompt is nothing but a message which you want to display. Enter the data, enter the first number, enter the second number. We have done this. So make your it's a good idea to make your program more user friendly. That is the idea. Okay. So after the prompt, of course, you have the scanf function. So what is scanf? Scanf is used to read data. It is a counterpart of printf, right? So it's used for reading data. So for this scanf, again, what is the syntax? You have the format specifier string followed by the variable names with the address of operator. So there's a difference. In printf, it's different. It's only the variable names. Here it is the address of operators. This is an operator in C which is called as the address of operator. Okay, the ampersand symbol that you see. So it tells the scanf function where to find each variable. So what is the memory location? This address of operator actually means I had explained this in the practical. I don't know whether all batches know it. So this is your memory, okay? So suppose you have variable miles here. Okay, it has every variable has a memory address. Every variable has a memory address. So the value of miles is saved here, but the address of miles is 1000, say. Okay. So if I write in C the expression miles, it is referring to the name of this memory location, that is miles. Okay. But if I am saying address of miles, this expression, then it is referring to the address of the memory location, address of the variable name miles. Now, if I have to modify some value, in via a function. So scanf is my function. Printf is also my function. Yes or no? Printf and scanf are functions. They are functions, right?
Yes,
Which are available in stdio.h. So if I want to modify some value through a function, then I need to specify the address of that value. I need to specify the address of that value. And that is why in scanf, you will, and that is what we're doing, right? Inside scanf, using scanf, we are modifying, right? Earlier it was some other value. I don't know, it was garbage. But now you're changing it to 10, whatever user has entered. Okay. So to modify, whenever you're modifying some value, you pass the address of that variable to it, so that you can modify it. Okay, that is the reason. And why it makes sense? It will make sense when you learn functions, pointers, and addresses. When you learn that gradually, you will understand the reason for this exactly. Okay, so for now, you just understand you are modifying it. That is why you are passing the address of that variable. Okay. In printf, you're not modifying. You're just picking up that value and you're displaying it on the console. It is all, that value is already there, right? So that is what is happening. This is the effect. Okay. There were two examples. One was for letters. So for letters, it was a char here. Can you see? %C. Single character will come here. So letter 1, letter 2, letter 3. So that is just example. It's okay. Anyways, so I'll stop right now. This is the return statement. Okay, return statement is, it's just showing you what is the syntax. Okay, use will come when you define your own functions. Return statement, you will come back to it later on when you define your own C user defined function. Okay, so we'll see extensive use of the return statement. This is a general form of a C program. Okay, so we'll stop.
In the return statement, do we need bracket 0 or direct 0 is fine?
Not required. Return space 0 is fine. This will also work. If it is an expression, then it is good to put a bracket. It is good.
Okay.
It is not required.
Okay, thank you.
Okay, general form is done. Yeah. I will anyways pass this. These are some more things. I'll pass this, upload this PPT on Classroom. Those of you, I've shared Classroom link, by the way. Did you enroll for Classroom?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes,
Yeah.
Yes,
Yeah. So these slides, I'll do them. I'll upload them right away. Okay. So thank you. That's all for today. We'll meet next week then.
Ma'am, I have a
Yeah.
question regarding the model submission. So, I'm from ETRX A3 batch, and we have done one practical session till now, the calculator one. So, do we need to submit anything on Moodle this week? Because we don't know the format or what to submit.